we are live on Twitch and YouTube. Hello, everybody. Welcome to our next live stream. My name is 𝗥𝗲𝗹𝗲𝗃. I'm a developer advocate at Timescale. And in today's stream, I have a really special guest, 𝗔𝗁𝗃𝗀𝗃 from Preset, which is the company behind Apache Superset, which is the topic of today. So, hey, Srini, thanks for coming on.
Hey, 𝗥𝗲𝗹𝗃, thanks for having me. Excited to be here. I think this may be the first Twitch stream I've been on in maybe forever. Yeah, I don't know. It's cool. It's
Really?
exciting. Yeah.
Yeah, it's really cool. I hope we're gonna have some viewers. We're gonna be looking at the chat to see if people have questions about TimescaleDB or Apache Superset, or just data visualization or databases in general. And really, today's goal is to show how people can use TimescaleDB and Apache Superset together. Oops, I forgot our background. There you go, much better. And yeah, one final thing before we start. The recording will be available on YouTube after this, so you can rewatch it. Also, if you're watching this on YouTube right now, if you're watching the recording, there will be links in the description that are relevant to what we will talk about and show today. And we will also put chapters under our live stream, so you can skip to the part that you are interested in the most. All right. So with that said, let me share my screen and let's get started. So as I said, we're gonna talk about visualizing time series data with TimescaleDB and Apache Superset. Just a quick agenda. It's gonna be really simple and really useful for those who are trying to visualize data and are using either TimescaleDB or Apache Superset and try to figure out how they can work well together. So first of all, we're gonna talk about Apache Superset. Then we are going to set the foundation for a fast Apache Superset dashboard using TimescaleDB continuous aggregates. And then finally, Srini will show off his dashboard building skills and Superset skills to build a dashboard, an actual real dashboard with Superset, with real data that is using TimescaleDB as the backend. And so with that said, why don't you, Srini, talk about Apache Superset, about the tool, and why it would be useful for developers?
Yeah, absolutely. So Superset is essentially one of the most popular open source BI platforms out there. BI stands for business intelligence. And so in the BI space, most of the vendors are closed source. And actually, that was one of the impetus for why Superset was created at Airbnb, which at the time had a culture of creating internal data tools and considering to open source them based on the kind of scale of problems that they had. And they were kind of stuck with some of their proprietary and closed source vendors. So they decided that, hey, maybe it's time that the world has a good open source alternative. And so that's kind of how Superset was originally created. So it's modern, it's open source, it's browser based, and it kind of for many organizations replaces their standard alternatives. The code base is essentially all Python and React with some TypeScript, and so this makes it basically really easy to scale the application. It scales like any other web application, and so our community is full of kind of web developers, backend engineers, DevOps people, as well as data engineers that like this kind of open source core and the ability to scale it out. And the community has bet early on some nice standards. So for people in the Python world, 𝗥𝗲𝗃𝗀𝗃𝗃 is a very popular ORM, and it's for us offers two big kind of benefits. The big one is we kind of expose a no-code interface chart builder that maps to SQL alchemy metaphors, and also this lets us kind of conveniently support a large number of databases that already have decided to support and work with the 𝗔𝗁𝗃 standard. So there's just a little bit more kind of custom work to do to support it. And then we have a large diversity of charts. There's over 60 charts that ship with Superset. And we actually did a meetup where you can, where we showed off how to make your own charts. And so we're hoping to make that even easier. So yeah, browser-based, open source. We want to support as many databases as we can and support as many charts as we can.
Yeah, one thing which I really like about Apache Superset is that as you have these like so many logos of tools that Apache Superset is compatible with, and it's really cool that if a tool or a database speaks SQL, it will probably integrate and work well with Superset, which is really cool because it basically enables you to use Superset with a bunch of tools. Like for example, you have a lot of tools here, but it's not just like if you, for example, if you can use Postgres with Superset, that also enables you to use Timescale and all the other Postgres-based tools out there to use with Superset, which is, I think, it's really, really useful.
Yeah, and one quick thing to add right there. I mean, I think we're definitely very long on SQL, and people are adding SQL interfaces. There's entire companies now that are building a SQL layer on top of their IT and admin infrastructure, and SQL is becoming a common standard for other things as well. And in theory, those can also work with Superset. So it's an exciting thing. So yeah, the two main workflows here is we have what we call Explore. So I'll showcase both of these in due time today, but we have this Explore no-code chart builder, which is what I talked about earlier, enabled by 𝗔𝗁𝗃𝗃. And this kind of lets people quickly generate queries that power charts without having to do a lot of, basically in a more declarative fashion instead of very imperative. So this is great for just very, very fast visualization and building. And the personas that we target here are kind of end users, data analysts, people who are less kind of comfortable doing the data pipelining. Then we also have SQL Lab, which is our kind of in-browser IDE. So this is great for people who want to write queries, and you can actually do all types of crazy joins and any type of valid SQL that your database supports, and then publish the results as a virtual data set for the rest of your team to use. So this is obviously loved more by data engineers and data scientists, people who want to do more data transformation in Superset itself.
Interesting. I remember when I first started to use Superset like regularly. It was not so long ago. It was like maybe 6 months ago. And one thing I already noticed, which I really, really liked, and I still like it about Superset, is that it's really quick to move from having data in a SQL database and then having actual charts, but also a complete dashboard inside Superset. And that sort of time between those two things, like Superset really minimizes the time between data to actual dashboard. I think that's one of the best things about Superset.
Yeah, and to add on to that real quick, I mean, our internal motto is to reduce time to dashboard or time to chart. And so yeah, that's kind of a big obsession for us, is just reducing as much friction as possible. And sometimes that means potentially less customization options, or slightly less bells and whistles for people who want true freedom that sometimes code can give you. But we're focused on kind of the most common use case and just making it as quick as possible.
Yeah, you sort of need to make a lot of decisions for the user to be able to make this happen.
Yeah.
One interesting discussion I saw on, I think, GitHub or somewhere else in the community is currently it's not possible, but it might be something for the future to use pandas with Superset. So I know Superset is using pandas under the hood. But currently, many, especially Python developers, they are really, loving pandas and the kind of transformation tools and functions that pandas provides. And I just saw discussions that people would love those kind of capabilities in Superset.
Yeah, I mean, to quickly add on to that, I mean, it's funny because when you in Superset, when you run the queries, or Superset runs queries on your behalf, it's the kind of in-memory representation is a pandas data frame until a chart is provided or until it's cached anyway. So in many ways, we're kind of half the way there. Pandas and Apache are both deeply integrated into Superset. But yeah, I actually came from the notebooks world, so I've been aching for a world when we can mix kind of a notebook and Python and pandas code as well, publish, do data transformation, and then clean up and then publish that as a data set that Superset kind of treats like any other database table. That's something that definitely would love to see at some point. Yeah.
All right, let's move on. Time series visualization types.
Yeah, so this is kind of just like a cool, fun little flex, preview slide just to show off some of the most commonly used time series charts. So, the roots of Superset are very much in time series data. Originally, it was created to work with Apache Druid, which I hear is some type of database. I don't know. Maybe Timescale is better. Who knows? But I know that Superset's origin was in time series specifically for Druid. At the time, it didn't even speak SQL actually, which is a whole nother interesting story. But so visual, like the most common viz types in Superset are time series charts. These are 5 of the most common ones, and even the non-time series charts, time plays a big role in all of them. So you can across all chart types, even if you don't have time on your x-axis or explicitly visualized, you can still filter the data that's queried by time. So time is a big kind of metaphor in Superset. So yeah, it's just kind of a fun thing.
Yeah, actually, now that I look at this slide, there is one type of chart which I started to really like, and I didn't think that I was going to like it. It's this one with the huge number, the KPI,
Yeah,
and then
a
you
big
have
number with trend line. Yeah,
big number with trend line. That's it.
yeah,
So I have a personal finance dashboard where I manage my finances, and I
yeah,
have some of these charts where it's just a big number. And initially I was using because there is another type of chart where you only have the big number
yeah,
and you don't have the trend line, because I was like, hey, I just want to know the actual value
right.
right now, and that's it. But then I switched those to this type of chart where you can see the trend line, and this way it basically becomes a time series chart. And I
Yeah,
realized that it's actually much more powerful. Like, there is a one thing to see the value right now, but it's another thing to actually get a high level view over the past, over the historical changes, and you can see all these in a very simple way, because it's a really small chart on the full dashboard.
yeah. I mean, to add to that, I mean, in Viz, in data Viz, the 2 of the most kind of common principles and important rules is like the first one is show the data, so whenever possible, show information, specifically. But the second rule is one of the main goals of visualization is to enable comparison. Just showing a value is often not very interesting, because then that immediately leads to the next question of, is this high, is this low, how was it last week, how was it in a different cohort. And so comparison is super powerful. I think for time series, the main benefit, just like in time series forecasting, where time is a domain for generating features, for predictive forecasting, for visualization, time is a very nice automatic comparison type of metaphor, because you're always interested, how is this value relative to the past or potentially the future. So it's a really great point.
Nice. Let me pull up quickly a comment from the chat, actually on YouTube, which was let me see. So, hi, great content. Can you mention if Superset plays well with hypertables that are compressed?
Compressed. Yeah.
Um, yeah. And the answer is yes. And we're going to actually talk about it later on. That, you know, at the TimescaleDB has this concept of hypertables, and then you can compress these hypertables. But if you look at it from the outside, you're trying to interact with these tables. These are going to behave like regular Postgres tables. That means that Superset and any kind of other tool will be able to interact with these tables without a problem. Now, one thing you need to make sure, which I actually experienced myself, like I had to wrap my head around it a few times before, which is if your query is slow, it will be slow in Superset as well. So Superset obviously won't be able to do some magic thing which will make a slow query fast. So first you need to create a query. You need to maybe test that you are okay with the query execution speed, and then you can use Superset. And if the query is fast, there is a really high chance Superset will be also very fast and show you fast charts.
Yeah, and to add to that, I mean, I think the way I think about it is that Superset really is a thin front end, a layer over your existing data stack, which is why kind of some BI tools have a big compute, ingest, and caching layer, and very deliberately, because of where data kind of databases and data warehouses and just the modern data stack is evolving. Even people who are making databases, like the Timescale folks, they actually much prefer that you let them handle the performance side of things, because then otherwise you have multiple layers of caching and a very inconsistent experience. So that we definitely ride on that philosophy as well. And Superset has a very thin caching layer. If you're showing the same chart to 1,000 people, like, yeah, we'll cache that. But if you want to do complex group buys and filtering dates and stuff like that, in many ways, we'd much prefer that the Timescale kind of flexes strength there. So so as long as you kind of follow the best practices of Timescale, then Superset itself will not add that much more time to generating your chart. It's quite minimal.
Right. Thank you for the question, by the way. All right. Let's move on. You guys have a cloud solution, as I
Yeah,
know.
so that's right. Something like that. Yeah, just like Timescale. Y'all have Cloud and Forge. We have created Preset, which is kind of Preset Cloud, our cloud-hosted offering of Superset. We have a free forever tier, so for people who just that they're like what they see and they just want to try out Superset. This is by far the easiest way. You just put in your email and you can try it out and have 5 people on a team and go crazy. And so this is kind of a really easy way. You don't have to deal with Docker Compose or Helm charts or Kubernetes or any of that stuff. So if you just want to try it out and play with data in Timescale, that type of thing, then I encourage people to check out Preset Cloud, and I'll also be demoing Preset as well. And it's the exact same Superset experience. So you can always also move back to open source if you'd like, and kind of go both ways. But yeah.
And as you mentioned, there are ways to get Apache Superset using Docker.
Yeah.
As I know, also there is a way to build it from source if some people
Yeah,
would
there's a few
want to
different
do
ways.
that.
So there's that for some people who just want to try it very quickly and don't want any type of customization, you can actually pip install Apache-Superset. It'll give you the latest version. So we kind of bundle everything as a Python package, including the front end assets and everything. So that's one way. For people, some people we've spoken to, nonprofits that run this on-prem, they don't even want internet access to their Superset instance. And so you can definitely just download the Apache Superset source code if you want from GitHub or from the Apache Software Foundation website directly. You can use the community Helm chart that's in the GitHub if you'd like. We have a Docker Hub a Docker Hub image for people to use. Or some people, I definitely run it natively all the time as well. I just have my backend server, my front end server. So many different techniques depending on your use case.
Awesome. And then a sneak peek of what we are going to show as far as dashboard.
Yeah, so this is kind of Attila came to me with kind of his excitement over stock data. So we decided for kind of this stream and to show off an interesting use case. I decided to put together this pretty simple dashboard. And the nice thing is it's pretty fast to make because again, a lot of the hard work has already been done, which is the data and setting it up correctly in Timescale and all that. So once you're in that position, it's pretty quick to just make these charts. And so just kind of a preview of data from different tech stocks that Attila has pulled in. So just kind of a sneak preview, and we'll go deeper later in the stream.
Right. And before that, let me talk a few minutes about, well, I suppose TimescaleDB, but also just in general, what I found to be a really good practice for fueling dashboards with data. Um, which is, so I'm gonna have a list of things, and Srini, feel free to come in and say, what you think of these things, or if this is something that you also experienced or not. But basically, so currently, so when I started to use Superset with time series data, and I used it with different types of data sets, what I found is that for data that is sort of small scale, you might be able to get away with just using the row table as is, and connect the table as a superset data set in Superset, and slice and dice the data, and then create a chart and build your dashboard. But after a while, if you have a lot of time series data, which can mean a lot of things in different setups, but let's say multiple, like tens of millions of rows or more, at that point, especially with time series data, it might make more sense to try to do as much as you can in your database, in our example on the TimescaleDB side, to transform and shape your data, uh, and try to do less on the Superset side of things, meaning that you should use Superset only to actually create the charts, and create a beautiful looking dashboard, and try to do less transformation type of work in Superset. Um, would you agree with that? Actually, I'm curious.
Yeah, I mean, I think that's kind of what I was suggesting earlier too, right? Was yeah, definitely whatever you can offload and kind of iterate within the queries directly, basically in the in the superset language, we call this the physical data set versus the virtual data set layer in Superset. Whatever you can optimize at the timescale level, definitely that's definitely going to be your bottleneck more often than not. And then there are situations where you have a fast query, but there's something about the chart that's slow or whatever, and that those are rare. But then you need to kind of more methodically look at the number of data points you're throwing on the screen, or other type of kind of browser limitations sometimes. But yeah, by far most of the issues people run into that I've seen in our community are um, in the data stack itself, so in the database itself. So if you can do more of that there, then that's going to be great. The other thing to mention as well is that I know Timescale has this time bucket function, and by default, Superset, in the attempt to be very general, defaults to using date trunk. And so the kind of hack that we have here that's cool is that Superset thinks any timescale DB is actually just a Postgres DB, and that's partially true, but it's partially also suboptimal. So certain timescale functions we still need to kind of add special support for. And so, yeah, so essentially, since we don't have that, I would recommend that you kind of invest more in timescale, and in doing these optimizations in the timescale layer itself. And also, it's less lock-in too. If you decide you want to move away from Superset, or you want to use another BI tool or another charting tool with timescale, you've already kind of centralized your investment in performance at the database level. So.
Yeah, and another very useful thing is that if you put together your tables or views in TimescaleDB, and then you use them in Superset, and then you have filters, for example, the filters will actually use TimescaleDB or Postgres indexes.
Yeah.
And that's really useful, because that's in a lot of cases that's what really going to make the query and the chart fast.
Yeah, and we'll demo part of this too. We'll kind of subset the data to a shorter time range, and it'll quickly update, and that's all because of Timescale. So yeah.
All right, next on our list, I think I might have mentioned this already, but I found it a good practice to create materialized views to achieve high query performance. And in TimescaleDB, what that would mean is that you use continuous aggregates, which are basically materialized views created for time series data, and as some of the benefits of continuous aggregates in the context of dashboards is that you will have pre-aggregated values stored in the materialized view, and because these values are already calculated and they are already stored on the disk, when you query the materialized view, aka the continuous aggregate, it will come from the disk, and usually that's what helps you achieve high query performance. Now, another useful benefit of continuous aggregates, and this is especially important because this is something that pure Postgres is not the best at, which is refreshing materialized views. And with continuous aggregates, there is a very efficient way to refresh continuous aggregates, meaning when you refresh a continuous aggregate, you don't need to. So TimescaleDB doesn't actually drop the whole thing and replaces the whole materialized view, which can take a lot of time if you have a lot of data. TimescaleDB just adds new records to the materialized view in the time period, in the time interval that you define. So, for example, if you have if you know that you refresh your continuous aggregate every single day, as an example, then you know that you only need to refresh the period of 1 day, and this way it's going to be much more quicker, much more efficient, and during the refresh you won't actually lock the table for a longer time, as it would normally happen with regular Postgres. And one final thing, which is also useful for dashboards, or can be useful in some use cases, which is showing the real time or the most up to date data on the dashboard. And with materialized views, again, it's pure Postgres. It's a little bit of a struggle because refreshing the materialized view can take a lot of time, and you probably don't want to do it too often. But with continuous aggregates, you have this really neat feature which we call real-time aggregates, which will basically combine the results from the materialized view. So the values that are coming from the disk super fast, it will combine those values with the actual table that is underlying the materialized view, and it will calculate the most up-to-date values as well. So at the end, what you see in the materialized in the continuous aggregates and on the dashboard is that you see all the data there is in the database, and it's going to be efficient because most of it will probably come from the disk, meaning the historical data will come from the disk, and just the most recent data points will come from the row table, or in TimescaleDB's case, the row hypertable. But that's going to be only a small portion of the full result, so you still have high performance. And finally, just to top it off, some TimescaleDB benefits in Apache Superset. So as we discussed, TimescaleDB is a Postgres extension, and Apache Superset integrates well with any Postgres database. And there's a really easy way to connect your TimescaleDB instance to an Apache Superset instance. Then, as I mentioned, continuous aggregates, you need to add them as data sets inside Superset, but that's also really easy to do on the UI using the UI. And then because of continuous aggregates, you can achieve fast query executions. And because of fast queries, you can have fast loading charts. And you can also, as we will show later on, you can also set different filters. So you can make an interactive dashboard, and everything can be really, really fast. And then finally, real-time aggregates, which means that you can build up-to-date dashboards that are fueled by continuous aggregates, but still has the most up-to-date data records and aggregations as well in the view, and meaning the dashboard will be up to date. All right, so enough talking. Let's do some demo, and we're going to first show basically what I just talked about. We're gonna quickly create a TimescaleDB continuous aggregate, and then later Srini will show how you can build a dashboard on top of a continuous aggregate that you created in TimescaleDB. So let me jump over to, oh, I'm already here. So let me jump over to 𝗔𝗶𝗺, which I'm going to use to create the continuous aggregate. And this is going to be just a really simple and quick example using our stock data set that we are also using for the dashboard. And so in this example here, we are going to create a continuous aggregate which will store Amazon stock prices in 1 day intervals. So instead of having the Amazon prices in 1 minute intervals, which is the row, which the row table has those 1 minute intervals, we're going to roll them up and create 1 day buckets. So for every day, we're going to have an opening price. We're going to have highest price, lowest price, closing price, and trading volume, and an extra column here to store the change percentage, meaning the change comparing today and the previous trading day. This is a very typical sort of open, high, low, close volume candlestick data set or continuous aggregates that many TimescaleDB users use. So I run this just to show what it looks like. Again, it's very quick because we're just using one symbol, but the dashboard we're going to show is actually doing this calculation for all the symbols. So we're going to have data for all the symbols, not just Amazon. But the cool thing about continuous aggregates is that once we created the continuous aggregate, you can query it just like a regular materialized view, and you can set additional filters. So for example, here we say that we want to see all the Amazon daily prices from the past 7 days, and it's coming from the disk. It's coming from the materialized table, so it's fairly slow. Fairly fast. And so based on this, if you look at this type of result, you can already use this to build a stock dashboard, because you have everything that you would need: the opening price and all the other kind of prices. Now, one interesting thing that you might need later on is, so first of all, you can create multiple different continuous aggregates. So you can create one for daily buckets. You can create one to store data in 15-minute buckets, or 2-hour buckets, or 2-week buckets. So really, whatever that your requirements are, whatever you need. But if for some reason you already created one continuous aggregate, you can always re-aggregate the results. So meaning, if we have Here we created this continuous aggregate, which includes, oops, not 1 week, 1 day candlesticks for Amazon. We can always use this continuous aggregate to just re-aggregate this into 2-week buckets, which is done by this query. If I run this, you see that we have now different time bucket values. Now we are creating 2-week buckets, which might be useful if you are trying to analyze stock symbols and stock prices in higher intervals, higher time frames. All right, so basically that's the main step to basically build a foundation for fast dashboards. And we try to keep it simple for now. So I'm going to hand it over to Srini and show how you can use a materialized view like this to build a dashboard. So I'm going to share your screen, if that's all
Awesome.
right.
Yeah. All right. Thanks for that great kind of demo so far on the data. Hope people have a little bit of context into the data that we're visualizing. So I have here kind of the team that Attila and I have created for this demo in preset. And so this is kind of so the examples database ships with every superset instance. So if you just want to play with some data sets, you can do that. But this is kind of the data that we're here for, the stock data. And it's pretty easy to add into Superset. You kind of put your host, your port information, your username, password, and what you want it to say, whether you want to use SSL. And there's also this advanced tab. So if you want to allow DML, data manipulation, you can also you can also create tables and views if you'd like. So kind of, if you don't use dbeaver or datagrip, even though those tools are definitely really powerful, and I use them a lot myself. If you just want to do basic stuff, you can do that as well. And yeah, and then you can also set a cache timeout and that kind of thing. In some cases, for some databases, you need to upload a root certificate. You can do all that as well. And you could also enable data upload. So if someone has a CSV, you just want to quickly get it in to Timescale, this is another option as well. Although, as we mentioned earlier, I mean, the more you can do in Timescale's interface, the better. So you would just hit finish, and then it would be registered here. And so from here, you can actually click to the datasets tab. So we have this kind of data tab, which has both this list of databases and the datasets. So we get our datasets, and then we can filter to just the data from this database, so TimescaleDB stocks. And you can see here a list of the data sets that have been manually added. And so in Superset, the kind of our design philosophy here is that because a lot of teams, even small teams nowadays, have multiple databases, and each database might have hundreds, if not thousands, of separate tables. Some are staging tables, some are just for tests, some are outdated and are deprecated, but just haven't been removed for some reason. There's just a lot of tables nowadays in people's databases. And so we actually, the philosophy of the Superset community is, let's actually encourage people to manually register and kind of opt in to the data sets and the tables that they want to see. And this is kind of a vernacular lingo thing. Data set is just kind of a superset kind of representation, Superset's internal model for a physical table in your database. We also have virtual data sets, which I won't talk about right now, but that's kind of the word. So for people who might be interested in that. So there's a number of data sets that we've manually added. If you want to add one and manually register it, you use this plus data set button here. And by the way, you can also, if you have a large team and you don't want anyone to be able to add to this, you can actually restrict their permissions and limit who can do that. And so we have here kind of a familiar UI. You just click stocks, database, you pick the schema. So you can even add other types of, there's like this, every database has metadata tables and that type of stuff. If you want to query that, you can also do that. But normally you're here in the public schema by default, and there's a number of data sets here So if you click it and you hit add, it'll be registered here. I've already done it. We've already registered a few, so I won't click add right now, but you kind of get the picture. So from here, you can actually dive into more information. So obviously here, there's just a list of basic information. For any of these tables, you can click edit and see more information. And so by default, it's locked, so people don't accidentally change it. We'll unlock it for now. And so this is kind of the physical versus virtual distinction. This is obviously a physical table. You can create metrics. So Superset does have a very thin semantic layer, which I've written about. So if you just want to add certain types of aggregations, we call this a last mile transformation. Again, you still probably are better off doing this in your database layer, but if you're really blocked and you just need to make a chart and it's due tomorrow, you still have the ability to do that. Here's kind of all the column information and metadata. You can also do calculated columns. So this is kind of interesting if you're trying to convert from rupees to dollars or euros to dollars or something like that, and you haven't done this in your database. You can create a kind of calculated column that has simple non-aggregate select statements. And then there's settings. So you can also tweak the set the cache timeout and set this at a table level. So any chart using it, for example, maybe you want to avoid overloading your database in certain situations. You can kind of force Superset to use the cache if you'd like. So these are kind of all admin settings. So from here, you click the dataset name, and then it takes you into this what we call Explore, which is the no-code chart builder. So you'll see here some basic information about the dataset, right? The columns, the types. Here's the metrics that are there by default. Every table by default just has count star just as a default, because that's what a lot of people use by default. You can also change the data set if you'd like. And here is kind of your main way to change visualization. So for this data, we have kind of 2-week bucketed data from a bunch of tech stocks. And so we want to create a time series chart. And so we have this viz picker. You can either search for things. So if we go to all charts, you can see a nice big list of all the charts that are available. If you're interested in time series, you can just search for time, or even go down here to time. Either way. And so one of the most common charts is a time series chart. So we'll start with that. You hit select there, and then this is kind of the time series slice and dice mentality brought in here as well. So you'll notice for every chart type, this date time filter and time grain picker is there for every single chart type, because it's really front and center to Superset's visualization philosophy. And afterwards, you just kind of add more information for charting. So if we want to look at, for example, the total volume across all stocks for a given time period, we would add the volume column, and then an aggregate is required as well. So we would just do sum, and then let's say we look at the last quarter, and let's go a little bit longer. Let's do last year. We can do by week, and we hit run query. And so this is a simple line chart, nothing super complicated. If you go down to the bottom, there's kind of a data preview panel. So if you want to understand and diagnose potential issues in the chart, you can actually look and see. So by default, this is basically the data that is the absolute minimum data required to power this chart. So this is kind of this is more or less what your database is giving you. So by default, we just render timestamps. Soon we're going to add a feature that actually pretty prints these into date time values instead of timestamps, which are a little bit hard for humans. And you can also look at the underlying samples if you'd like. So this is kind of actually looking at what does my data look like, right? So when you're building charts, my background's data science, so you always want to understand what is the structure of my data. Sometimes that means just looking at 10 rows in its kind of naked resting truth value, right? And this is a great way to get ideas as well for new charts. And so from here on out, it's pretty straightforward. You have this aggregated value, and we've done it by week, and so it's kind of shown at the week level. If you want to see the query that's generated, every chart, because Superset is creating this query on your behalf based on the options you picked, you can actually see the query that's run. You'll notice here we used date trunk, right? So eventually this will be switched to time bucket. For now, this is still date trunk, but Yeah, so this is the query that's generated, and as you change the value, you'd expect the chart to change, the data that's queried to change, as well as the query. So you'll notice here how quick that refresh was. And so you can actually see it ran in a second. And this is, again, because we're kind of requerying the same data. And I'm guessing it's tapping into an index that's available underneath, or the continuous aggregate. Either way, we're able to kind of change the time grain, and know that that it's going to respond very, very quickly. So that's cool. Yeah, 2 seconds. So again, invest in your database whenever possible, because Superset is a pretty thin layer over it. And this is where the caching comes in as well. So if you hit run again, you'll notice it returned in basically 0 seconds because we hit the cache. You can click force refresh here; it will force refresh. So this is just for if your data is not changing, you can offload some things, but just be careful when you use it. And then from here on out, you can kind of take ideas that you have and quickly iterate. So if you're tired of lines and points, you can switch to a bar chart. We do time series bar chart v2. The settings are brought over, right? And so in just 3 seconds, you've just switched to a completely different chart type. You can go monthly instead if you want. Switch to monthly. You can do group by. So if you want to instead group by just a few stock tickers, you can do group by symbol, but we have like 50 stocks, so that's too many. So we can filter that down, just to where's symbol? Here we go. If we just want to pick a few stocks to do the faceting, then we can do just us to Apple and Airbnb. Who do you think has more trading volume? I think we could probably all guess. So we hit run, and we can clearly see that Apple is way more. This is a monthly time grain. So February, March, April, it's over 20 times more volume, for trading volume for Apple versus Airbnb. And so you can kind of go at the speed of thought, right? If you want to add more stocks, you can do that as well. It will take up more space, of course, but all these queries they're fast. This is under a second. Again, this is because of Timescale. It's not because of anything we're doing on the Superset. And so we can add and remove stocks, and it'll re-trigger it in under a second, I bet. So yeah, and you can also change the chart type. So you can change it to scatter plot if you want. You can add an area chart if you actually want to look at how these things are stacked up. So we can kind of, I'm kind of tossing out ideas, and by the time I'm finishing the sentence, we've already seen the chart. So that's kind of the power of having a fast BI tool, essentially. And so then when you're done and you like the chart, you can hit save. You give your chart a name, and you go assign it to a dashboard. And so I've already kind of assembled a few here. So we'll kind of dive into the ones that I've created. Before I go into this, any questions? I'm curious if people have questions, or if you want to pause before I kind of go into the second half.
Well, first of all, I just want to say this is really cool, especially um, as you said, you come from a Jupyter notebook kind of world, where I suppose you do something very similar. Like you just sort of create a chart, you modify
Yeah.
some values, you see what comes up, and it's very quick to do in like Python. But it's also like, as you can see, it's very easy to do and quick to do in Superset as well. And that's really good, and that's really useful, because you can use like a UI, and you just click around, you just say that, hey, I
Yeah.
want to group by this, and then you have the chart already there very quickly. And then you can decide to put the chart on a dashboard if you find that that's a really useful chart and you want to look at it multiple times. So that's really
Yeah.
cool.
Absolutely. And I think, I still love using pandas and notebooks for a lot of things, but I got to say, well, I don't miss not having syntax errors anymore, and just being able to kind of have ideas and quickly iterate, and then publish that into a dashboard. I've interacted with teams that they go from idea to a completed dashboard in under an hour. So that's great. And that dashboard is now available for an entire team to use and get value out of. And so in this kind of world where people are treating these type of dashboards and data sets as products, being able to quickly build a product and iterate on it, even if it's for your internal customers, that's kind of a huge win. So yeah, I'll kind of we'll dive into this kind of fun data set, this fun dashboard here. So at a high level, we have kind of tabs. So this is just a dashboard. So if you go to the dashboards tab, you'll see a full list and you'll see stock dashboard there if you were on this instance. And within that, you can have as many tabs as you want. And so we just have 2. And I would say it's generally best practice. I would not have more than 4 or 5 tabs. I'd actually recommend people really just consider making more dashboards instead of trying to cram more charts. I've seen a few people in the community also ask us, hey, can I put like 100 charts in a single tab? And I would strongly advise against that, mostly because, first of all, there's some browser limitations. I believe the browser can only do 5 query requests at a time to your backend server, in which case would be Superset. So if you have 100 charts, even 20 charts, you're kind of asking for a slow, bogged down experience. And also, charts. The whole point of visualization is not it's not really pretty pictures alone. It's really to drive a decision. So people do get that decision and information fatigue. So you'll notice in the dashboard there's only a few charts. It's very focused. If anything, I'm using this filter mechanism over here to add more dynamicness, so to speak, into the dashboard. So just kind of a meta note right there. And so the way to kind of customize your dashboard is you'll see here that I hit this pencil. I'll show it again in case you missed it. But you click this pencil and you can edit any of the dashboards that you have permissions to. So you hit edit dashboard and then you can move things around. And there's kind of this grid where so you can add a new chart, for example. If we were to do that, you can put it in this bottom row. You can add a markdown element. So if you wanted to put a cell and explain what this dashboard is, and you can even pull in like images if you want. So kind of really sprucing up the dashboard. It does not support like JavaScript and stuff like that. I know people often ask about that. This isn't a full-on kind of app platform at the end of the day. It is a dashboarding tool. So, but it is nice for adding context and putting some explanation. You could put information on, hey, this data was last updated an hour ago, or here's the person to ask if it looks wrong to you or whatever. But to make these tabs, I basically just pulled in this tab component right here, and then it'll slot into place. Once you have a tab component, of course, then it'll just expose this plus button for you if you want to add more tabs as well. So we won't do that right now, but just as a preview. And then once you're done editing, then you can, editing the layout, you can hit save, and it'll basically refresh and publish this dashboard as well. So we'll kind of dive into data here. So we have kind of, I think, data on about 40 or 50 different stocks. I don't remember the exact number, but I decided to kind of facet these in interesting ways. So here we have, I don't know if FANG is the right term anymore, because Facebook changed their name, and
Mang,
there's also like
probably.
Microsoft. There's like Mafia. I think someone's trying to make like Mafia happen. I don't know. And people don't consider Microsoft part of FANG. I don't know why. Anyway, so this is just like a number of tech stocks that I follow and I find interesting. And so this is data from the last year, so 2021, and I think it tells a pretty clear story that pretty much every tech stock did pretty well, regardless of kind of the share price. So what I have in blue, so you can also, I've decided to hide the legend just because I didn't want 6 different legends on a single dashboard, but you can in the edit button, in the advanced view, you can actually add the legend. But the blue is basically for each given day, the highest price it hit that day. So this is not the open or closing price. This is just purely the highest the average share price hit. And then you have min, which is the lowest for that day. And we can see very clearly that the tech stocks did well. I think that's kind of been an accepted narrative at this point during COVID. And so all the tech stocks did really well. And we can filter this date range down. So one cool thing is any filter in this corner here, you see a list of all the filters. In this case, we just have one that applies to these charts. When you hover over the filter, it highlights. This is a cool kind of hackathon feature that project that we added was, hey, I want to know like how the filter is mapped to charts. And so why have a settings panel? Let's just show it when you hover. So it's kind of a cool design thing that we added. You can also see the filters that are out of scope. So these will not apply to these charts. And if you want to make a filter of your own, you just in Superset, everything kind of editing related is a pencil. And so we basically just can enter this filter view and add any filter that we want. So in this case, if you want to filter by date range, that's the picker that we have on the left. It's actually one filter type is the date range. is the time range filter. And the cool thing here is you can actually set it up by default. It'll actually apply. And this is again showing the time series roots for Superset. If you have 8 different charts querying 8 different tables, you can actually have the time range filter apply to the datetime default column for all 8 of those charts and all 8 of those tables, which is pretty powerful and pretty unique to Superset. For all the other filters, it's more dataset plus column, dataset plus column. So it's scoped down way more, but time is that magical thing that I talked about earlier in terms of Superset, where it kind of transcends specific tables if you want to. And so just to kind of show this off a little bit, we have this time picker here. We can go from a specific date. Let's say we just want to look at February 1st of 2021, and we maybe want to look at, I don't know, July. This is just kind of a restricted window. We select it. You do have to hit apply. You can change it. You can change the filter so it's instant. But I've decided kind of against that because it does create more queries, which you may not want. And so you can kind of filter things down pretty quickly. And that updated very quickly. This is 6 different queries, by the way, and it's still updated very, very fast. So let's say we change the date again. We hit apply. We hit apply. This is under a second. This is 6 different queries under a second. Again, speaking to the benefits of Timescale really here. And we can also go to this other tab that I've created. So these are all the stocks. So this is looking at trading volume by stock. And so this is kind of the long tail. As we kind of found out earlier, Apple is a highly traded stock. And so I've created a filter here to actually scope this down. So if I wanted to only look at Apple and maybe Tesla, maybe Airbnb, and Amazon. Let's say we use these 4, we hit apply as expected. It returned very quickly. And so the scale, the x-axis scale, obviously changes based on the number of categories that you have. So we have 4 giant bar graphs because there's only 4 stocks that we picked. And so we can kind of keep adding more, hit apply, and it refreshes very quickly. And it feels really lively, which is great. The last thing I wanted to show as well is this fun little Explorer stock dashboard that we made. So let me just remove all these real quick. And so in this case, we have the daily low versus the daily high price. This is across all the stocks. Actually, sorry, in this case, this is just Apple. So you can look for the month of April to August. This is kind of the range. So if you remove these range, so my kind of default go-to is no filter. If I just want to look at all the data, you just hit no filter, and then you'll see both the charts. This is like, under a second, right? And then it just had to render the charts. And so this is kind of and I think it's not quite a candlestick chart, but it is a way to look at time series data. So this is high versus low. So this is kind of, I generally like this dashboard design, by the way, where you have your first tab be very high level in general. So these are overall trends. And then you have a view. I always put a magnifying glass whenever I want people to zoom in and think about zooming in more. And then you have a view which is just focused on a specific stock. And so you can really go crazy and just zoom in more. But it's hard if you're going to show that level of granularity across 8 different stocks. It's a little bit more difficult. So having a separate place for both flows is very powerful. And that's what tabs lets you do. So you can change the stock right here. We can go to Adobe instead, another company that I like. And you can see the charts changing. And here on the bottom is actually a calendar heat map. I'll kind of pop this up real quick. So any chart can be force refreshed if you feel like it's hitting the cache. You can also view this chart in the no-code interface. And I'll kind of quickly show, I'll end by quickly showing how this was generated. So it's a pretty simple chart. It only requires a few pieces of information. So it needs to know what the time column is. Again, in Superset, time is huge. Every database table really wants to attach itself and figure out what the heck is the datetime column for this table, because then I can use it everywhere. We have this time range. This is passed down actually from the filter context earlier in the dashboard. And then you just select the domain. So if you want hours, days, weeks, or year, and then the subdomain, in this case, days. The metric is trading volume. So I did a fun thing where I actually took the volume column, summed it, and I used this pencil to give it a name so we don't see sum volume everywhere. And then this is the filter context. You'll see right here, this filter was inherited from the dashboard's context. It won't be saved when saving the chart. So there's also another way to prototype different values right here. And then based on the range that we put here, this will obviously impact the chart, and you'll notice that those months will actually be hidden, so we don't see a bunch of grayed out values. And when you're done, again, as usual, you hit save. In this case, save it to your dashboard. You hit the edit dashboard view, and then you can see it listed there, and move it around as you see fit. So yeah, so that's kind of a tour of the dashboard. I hope people found it useful. Happy to answer any questions or kind of go a little bit deeper on some things.
Really cool. Thank you. Well, one thing that I noticed is that so the way you use the tabs to create these sort of separate pages, is that like so are those just regular tabs uh, that you can just pull in, and then you just put all the other stuff in there? Because I
Yeah,
didn't know
absolutely.
that you could use tabs like that. That's really cool.
Yeah, it's a little bit hidden, especially for it. Yeah, it's a little bit hidden, but you can basically pull in tabs. I'll do kind of a concrete example here. So tabs exist at kind of the dashboard level, and confusingly a little bit, they also exist at the tab level. And what I mean by that is you can actually pull in a tab right here, and let's say we wanted to have two different views, low versus high, and then we can just edit this chart. We can move it into this view right there, and then we can add trading volume as well. And then this should be, there we go, pulling in there. Okay. And then if we go here, we can pull this in right there as well. You hit save, and then now each tab has a different context. And also this works great when if you want to scope down your filters, right? So if you have stock ticker, you can actually choose the scope down to the sub tab level. So we have the first level of tabs, which is just tech stocks. We have the sub tab called comparing stocks, and so you can really filter it down even to the chart level. If you want one filter to only apply to one chart, you can do that. So these things map really nicely together. But yeah, it's just in this edit view right here. You can just pull in the tabs that you need.
How do you? I think you mentioned that you can pull in images.
Yeah.
How do you do? Is it like a hack, or
It,
is?
yeah, it's a good question. It is a little bit hacky. So by default, we have this like Slack dashboard that we call it, that we build, and so this is a good one. It's a
Mhm.
good reference one where you hit edit, and then you double click. Sometimes it takes a second, and so we're iframing in. Whoops. What we're doing is essentially, sometimes this one's a little finicky. We're essentially iframing in the SVG logo
Mhm.
from Slack server, from one of their CDNs. So you'll notice here, so this is a markdown cell, so you can put any type of markdown, but it also takes in HTML and CSS. So you can put an iframe value. And so people will use this type of iframe to embed, sometimes charts from other tools or context from other tools that they've made publicly available. But yeah, in this case, we're just iframing in Slack logo. And so yeah, Superset, again, it is a thin layer, so there's nowhere you can't upload your image into Superset per se. There's no data store for Superset. There's no image store or content store. But if you have an image already, let's say you have it on S3, Amazon S3, or somewhere else, or it's just a public image, you can just reference it here. And then when you click out, it'll pull that image in and render it for you. So that's it's a little bit hacky, but
I see.
is something we've seen people do. Yeah.
Yeah, one thing I because I was working on a dashboard where I wanted to include some image,
Yeah.
and I think I ended up using just a table where I had the actual like the link as one of
Yeah.
the columns in the table, and put that in like HTML uh, tags, uh,
Yeah.
and that worked.
Yeah, you can also do links too. Like we had a GitHub dashboard that we've written about, and that one was cool because we actually like use a calculated column to add HTML to the results of a query. So we add like the opening HTML tag href equals, and we kind of generate this HTML that's dynamically generated from a GitHub issue URL, and then we make it clickable. So same thing, you can make a table of clickable links that's dynamic to your data as well. So yeah, all kinds of cool things like that.
Awesome, great. So I know we are a little bit over time, so let's maybe wrap up. So Srini, thank you very much for joining me today. It was I think it was a great stream. We showed some actual practical tips how people can get started with these two tools. So that's really great. Where can people like reach you, or if they have questions? I think you guys also have a Slack community.
Yeah, that's right. I'll quickly. Yeah, if you go to superset.apache.org/community, that's a great place to figure out how to join our Slack community. And you can also reach out to me. I'm Srini at preset.io. So SRINI at preset.io. Happy to answer any questions or be of help however I can. And yeah, and then preset.io obviously is our domain name. We have future events, so if people are interested. I hope we'll do one with Timescale as well on our end. So preset.io/events is another place for people who want more superset and data viz content. So yeah.
Awesome. And we're gonna if you're watching the recording, you can also leave your questions in the comment section on YouTube. We are going to be looking if there's any new question, and we will trying to answer those. All right. Thank you again. If someone wants to join the Timescale Slack community, there's the link slack.timescale.com. And we are happy to answer any more questions or continue discussions about Superset and TimescaleDB and other database things. All right. Thank you, Srini, again. It was great. And
yeah, thanks for having me. This was fun.
Awesome. Bye, everyone. See you later.
Thanks for coming.